Howdy and what's going on? This is John Sisson and this is my first YouTube video, which is going to be about converting a Lambretta scooter 6 volt output stator, in this case the 6-pole battery model stator, converting that to use with 12 volt output in a 12 volt battery system on the scooter. So let's give it a spin. Now it really must be pointed out at the onset here that you don't really need to hand wire or rewire the 6 volt stator in order to come up with a 12 volt unit for your bike. There are numerous kits out there that you can just go buy, ranging from probably $2 to about $600 or $600 or so. But I thought it'd be interesting, fun, educational to do this, probably as some of the first cave pioneers of stator rewiring did it, which is just by hook or by crook. So I'm going to try some different things, and I'm certain to come out successfully. And I'll show you how I did that. And maybe I'll show you the outtakes too, because I'm sure there'll be some. All right, now at this point I thought it might be worthwhile to talk about the variations of 6-pole Ducati stator, which Lambretta used, from the advent of the 6-pole up until maybe DL. I don't know what the DL's like, so I'm not going to talk about those. But the one iteration of the 6-pole is the 6-pole magneto without battery. That's this one. It uses purple, pink, green, and brown wires output. The green circuit is the ignition circuit. It's coil number 3. It's opposite the points, and it's always opposite at the points on all the 6 poles that there were. And on the non-battery stator, one coil was used to drive the brown wire. One coil was used, number 5, to drive the purple wire. And 2 coils in series were used to drive the pink wire. Those are numbers 2 and 5. I'm sorry, number 4 here is the purple. But number 5, here comes the pink wire going into this coil. The connection goes over to the 2 coil and then ground, so it goes like that. But anyway, that's the layout. 1 coil for brown, 2 for pink, 1 for purple. So let's move on to the next stator. The next type 6-pole stator is the battery bike model, where instead of brown, pink, purple, and green, you have brown, green, yellow, and yellow. And on this bike, 2 coils are assigned to the brown wire in series, numbers 1 and numbers 2. Number 3, again, drives the ignition. We're not interested in that for the sake of our rewire scheme. But coils 4 and 5 on the battery stator seem to be split into 2 coils. There's 2 on each bobbin. So how they're wired is half of the bobbin, number 4, is wired in series to a corresponding half on bobbin number 5, and then outputs as one of the yellows. And similarly, the other winding on bobbin number 4 connects in series to its corresponding other winding on bobbin number 5, and it goes out as the other yellow wire. So and each of those series connections are grounded. So the circuit begins at ground, goes out through the 2 different yellow wire circuits, and goes up to the rectifier. So that's the 6-pole magneto. Now this last one is the 12 volt conversion scheme as illustrated in the Home Workshop manual, where again you have 5 coils. Number 3, opposite the points, drives the ignition. But this time you just have 3 wires out, the green and 2 yellows. And how this is wired up is coils 1 and 2 are in series. However, they're not grounded. See, one side of the series goes out in one way, the other side goes out the other way, but 1 and 2 are in series. Then we have 2 similar coils, also called 1 and 2 here, not 4 and 5. Maybe because they're identical, I'm not sure. But that pair is also in series. And what happens here is the 2 pairs of series are hooked in parallel. In other words, these windings come over and parallel into this pair in series. And then the yellow wires go out from there, and those are the two yellow wires that leave. So you have two series paired sets of coils wired in parallel and going out to the rectifier. That's the Lambretta 12-volt conversion, which was a kit which you could buy and install back then. But that's how that one goes. All right, well, this is a little makeup section. I had previously, a few minutes ago, talked about how the pink wire circuit was comprised of two coils, with the pink wire coming in, going to coil number 5 and out of 5, over to number 2 and out of 2 to ground. Two coils on the pink wire circuit. And the diagram shows one coil, ground, out to brown wire. So one coil on the brown wire circuit. In actuality, it's the reverse. The brown has two coils and the pink has one. So the home workshop manual, it would seem, is wrong. And I've got to conclude that because I just procured two swell AC stators from Barry Gwynn at San Francisco Scooter Center. Thank you, Barry, for all your help. Barry, you're the man. And with the real deal in your hand, you will see the following. That the brown wire comes in here. There's the brown wire coming up. It goes into this coil. It comes out of this coil down here. And it comes up to this terminal. And there is a brown wire connected at the end of that coil, which comes out of here. Is that showing up? Yeah. Comes out of here, goes under this coil, and runs along under the ignition parts, and comes out over here and goes to this coil. And comes out and it loops into that coil, comes out of that coil over here and grounds. So, and as relates, the pink wire stator simply comes into this coil, comes out of the coil and grounds. So in actuality, the brown wire circuit has two coils and the pink wire has one, contrary to what the home workshop manual says. But that makes sense because the brown wire is driving the headlight, which is the big ticket item in terms of lighting draw on the Lambretta. So I just had to correct that. Brown wire has two coils, pink wire has one. All right, so with all that background about the different types of original coil configurations, we'll go ahead and talk about what I've done so far with this thing. And the first thing that I did was put the stator into a bike in its stock correct configuration and hooked it up and took voltage readings at idle between ground and one of these yellow wires. And at idle I was getting 2.5 volts. And when I revved up the scooter somewhat, I got it up to about 10 volts AC. Of course, no load, no lights running or anything like that, just from wire to wire. And then I took the stator out and I did something that I had heard about one time, and that is that I disconnected the grounds of the two coils on this bobbin, which are coming out down here, and they're coming over here, and they're soldered together, and they're also soldered to this ground lug here. Well, I disconnected them from the ground lug, left them soldered together, however, and then took that and went and put it back in the bike and started it up again and tested, this time between the two yellow wires, because ground is no longer involved when those are ungrounded. The circuit is from one yellow wire through the lower coil here, which then connects to the lower coil here and comes out as one of these grounds, and then it touches the other ground, goes back to, say, the upper half coil here, which connects to the upper half coil here, and comes out as the other yellow wire. So that gave me an idle voltage of 10 volts AC. And when I revved up the bike, it went up to about 20 volts. So that was interesting, just by ungrounding one side of that circuit. The next thing I think I'm going to do, so looping those things through the two output wires gave me 10 volts. So the next thing I'm going to do is look at these other two coils the brown circuit coils here, which are these guys. And right now, they're connected together right over here. And one side is grounded of this coil that comes out, connects to this coil. And here it comes out and attaches to your brown wire. So there's two coils in series going out the brown wire. And what I'm going to do is I'm going to unground this coil over here. And I'm going to attach a wire to that. So, and run that out through the harness. So, and then test that and see what kind of voltage I get running those from wire to wire instead of wire to ground. All right, so I'll take that out and put it back in a bike, and I'll be right back and tell you what happened. All right, so we're out here on the test mule TV175, and I'm going to see what we get as a result of me modifying the brown wire circuit of the 6-pole battery bike stator, where I lifted the ground of the two coils in series circuit, which comprises the brown wire circuit of the stator. And so I'll go fire it up and see what we get on the meter. Well, so far so good, so let's take a look at the meter and see what the meter says. So it looks like we got about 10 volts on the 0 to 50 scale of the meter. I'll go rev the bike up a little bit. So I couldn't watch the meter, but I bet it went up. I'll take a look at it. And that's all for now. All right, now here we're going to take off the old wiring harness. First of all, these two yellow wires here. So let's get some slack on them. There we go. There's one. There's two. And then I can use this video to see where I took them off. And then I'm going to take off the green wire. Now let's take off the this red wire first. This red wire is one that I just attached to what was the ground location for the brown coil. So let's pull that out. Get some working room for that. Then let me turn this off momentarily while I cut away that shrink tube. There we go, so the shrink tube's off, so now I can remove my temporary wire, my experimental output from what was the ground of the brown wire coil here. There, that's off. let's go over here and take out the green wire. How's that lining up? First of all, let's pull a little working room out of the green wire so I can get a hold of it. There we go. And there's the green wire. And then we still have a brown wire, I believe, to get out of there. There we go. So the brown wire's coil is detached from the brown wire itself. And let's give myself some room on the brown wire. Get the green wire out of there. Pull some brown wire up. And let's try and get that brown wire out without doing too much damage here. And there we go. So the old wiring harness is off, and I'll pull it out. Okay, in this next segment, I am going to show what I'm doing as far as wiring up these coils in series. The ultimate goal here, I think, for what I decided to jump forward straight to is to wire up this coil, this coil, this coil, and this coil in series. And so, what you may see that I've already done is that I brought in my new yellow wire here, which comes up here and it goes in here and it attaches to the beginning of this coil, which was a ground connection. So I lifted that ground, connected the yellow wire to it, shrink tubed it, put it up through this hole in the bobbin there, and out it comes as my new yellow wire. Then I'm going from, well, it was already wired up. That was the ground side of this coil. The other side of the coil did come out and goes right up here to this coil, and it goes into this coil. And then it comes out as this wire coming out of this coil, which was grounded, but I lifted that ground and I connected this piece of wire to it. And I got this swell wire, by the way. I went to my local electronics surplus store and I bought a fluorescent light ballast tube. And the ballast had all this wire connected to it. It was all this stuff. It's just tons of it. And it's just this right gauge. It looks like about maybe 20 thousandths or so. And I got the ballast for $5, and I just got tons of this really nice copper wire. So that's how I got the wire. Went to the electronic surplus and bought a fluorescent ballast with all this tons of stuff connected to it. It was cool. So anyway, so I wrap these wires around one another. I'm gonna solder this wire over to here. I'll go over to that in a moment. But I'm seeing as I do that, and I also ran my new green wire into here, but I see that it's sticking out a lot. And so I am going to try and push that back out of there so that it isn't so close to my new wiring here. So just going to try and heat this up. Here, first of all, let me get some green wire out. Get some new green wire out so that I can pull it. There we go. So that should prove a good handle. So now I'm just going to heat this guy up. Is it on video? Yeah. Just going to pull it out a little bit. Yeah, that's kind of good. Let's try that. That looks good. We'll take a look at that. And I also see what I want to do. That's also the connection for the black wire that comes over here, and then it comes over to the condenser and then goes to the points. So I'm going to try and smush that black wire down. Just kind of over out of the way. There we go. Beautiful. Excellent. So now what we got is more room for this wire to be in here, and I'll put some shrink tube on that, and I think what I'm going to do is hold that, bend this away, to create some room between this and this ignition stuff, because if they're leaning on one another, then over the miles that will vibrate through the shrink tube and probably short something out, so you want to be cautious about that. So let me get a little piece of shrink. So right now, so it's one big long daisy chain of coils. And you can see that pushed that winding up out of there. We want as much length as we can get. So there we go. So I really want that shrinked down for reasons which we will soon see. And I think I'm getting a little more shrinkability here. That's probably good. I'm going to take another piece about the same length. Yeah, that should do it. And I'm going to put it on top of that piece. Like that. Get it out of the way for a second here. I think I better cut it a tiny bit shorter. There we go. So I saw that flow across the various pieces of metal. So now what I've done is connected this coil to the two ground wires that are going into the two windings on this coil, because this is a DC stator, a yellow wire stator, and there's two wraps, and there's in this bobbin. There's two in this bobbin, and the beginning of each of those two are this wire and this wire, and they're coming together. They used to be grounded together, but now I'm taking this coil and running it into both of those. That's that joint. And then I'm going to take my shrink tube that I put it on there, move it on over. I'm going to give that a blowjob. Oh, that's hot. And there we go. So now, what we have is we're just about done here. we're going into those two coils, and the two wires coming out of these two coils are right here. There's one down in there and there's one here. And this one comes to this junction on this coil, and this one comes over to this junction, and from there they go into the two wraps that's in this bobbin, and they were coming out of these. The two previous yellow wires were here and here, but I'm going to join those and put a yellow wire on here. So let me pause the recording while I get that prepped. Okay, now over the break, I thought about how I was going to do this. I was going to come up with a yellow wire and connect it to there and across to there, but there's such little space right here for that big yellow wire to go that way that I decided I was going to do this. And that is to take some of my hookup wire that I bought and tin it. Okay, we're going in. And this is one of the locations where one of the yellow wires, let me wipe off. One of the yellow wires used to be here, and I'm going to heat that up. Let's see if I can go right in there. Here we go. Then let's take this over, bring it down there like that, and then keep going, probably like that. That should be good. Yeah, that'll work. Just I'm going to solder our hookup wire to this terminal, which was the other yellow wire location. And come back here and make sure this side is done well. Here we go. I think that's good. And I'm going to come in here with a new yellow wire. This wire, yellow wire I'm using, is really mofer stuff. It's like 14 gauge or something. It's just what I had lying around. So I'm going to attempt to wrap that. Why don't I do it up here? Leave it right about there. And give that a little solder action there. Feels fairly smooth around there. I think I'll just
smack that little wire down a little bit. There we go. And then straighten it out in this dimension. So it's kind of concentric all the way around. What's the next step, you ask? Yeah, that's down about as much as it's going to go. Okay. It's alive. And there's our yellow wire. So now you see what we got in the way of a circuit. We have a yellow wire coming in going at the beginning of this coil, coming out this coil, going to this coil, coming out of that coil, going over to here, coming out there, and going there, and coming out here. So that's the big goal. So I'm gonna, let's talk about one more thing. Put this whopping 14 or so gauge wire through here, which we'll of course need because of the overly, ridiculously high amount of amperage that we're going to generate. Put it here, and we're going to carefully sort of route that wire. And so there's what do we got. Okay, just like that. So now we've got some space between the points and the wire. And just to emphasize that, let's just push through here, kind of smoosh it over. Yeah, now we got like a good 1/16 of an inch of space there. Right in here. Plenty of space. And then one thing I thought of doing was, and I'll pause the recording for a second. One thing that I thought about doing was to take zip ties and pull them through here. And hook them up. And zip them and tie them. So I'm going to put that right there. Zip that up nice and snugly. Click, click, click. You get those last few clicks. Maybe swing it around here. Get rid of the excess. And so that should secure this wire from being pulled inadvertently. It's just a safety and a strain relief. And I think I'll go ahead and do that to the other wires too, because that's a cool idea. Make sure that we're not pulled too taut before I do that. Get some slack in that wire. Yeah, that's good. Click. Get the last click. And nip that off. And then finally do the green wire. Green wire, we're gonna push it down like that. So just flush in like that. make sure it's out of the way of the flywheel, which I think it is. How's that look? That looks good. Okay, so that is all integral now, and then looks like we're going to want to go this way and out. This way, and probably this way. There we go. Let's make sure we have enough room there. And so that's what that's going to look like. I may tack down some of those wires, yeah. I want to tack a couple of those down. Joke. Now all we need to happen is for this not to fall back through the access hole. That should stay there. There, so that keeps those wires there. Yeehaw, so let me go get a big piece of shrink tube. Be back in a second. Okay, so now that we've finished wiring this thing, I think one thing we ought to do before we go any further is test it. Just do some simple tests to make sure. So here's my little continuity meter, and I'm measuring from yellow to yellow, and we have continuity. Oh, look at that meter. Oh, look at how much continuity. Oh, that's wonderful. And then the yellow circuit to ground. Oh, we have nothing. Oh, too bad. No, that's good, because we don't want anything in our charging circuit to be touching ground. So we're looking good. And then do we have anything going on between charging circuit and ignition circuit, otherwise known as the green wire? No, we got nothing. But we got something when we go, oh, look at that. So the preliminary continuity tests say yes. There, now that we're happy with indications of the circuit being successful, let's throw some bullets on there. So first, and I stripped it about 3/16 of an inch. And then you crimp the middle part of the bullet. These are pretty robust brass things. Let's just say that those are solderable. Spin that one around a little bit. So there we go. cheek in the shot? No, I don't think so. Okay. I think I did the green one first, so now let's crimp the jacket crimp. Well, that's probably good. Yeah, where'd it go? There it is. When you do the soldering, the jacket, the plastic jacket recedes a little bit, but it's so solidly wired, soldered on there that this in a way doesn't really matter, but looks cool. There. So there we go. So next stage will be to go put it on the bike and see what happens.
Well, so far I've done about 50, 60 miles on this bike, and the voltmeter just hangs in there at about 11.5 volts, 12 volts. And so I think for my last experiment, I'm going to discharge the battery before I go out for a ride, and then go out for a ride and see if the thing recharges up to that same 11.5 or 12 volts. Careful scrutiny will belie the voltmeter, which I have integrated into the TV2 headset, and it goes down here and goes in there and connects to the battery. So I'm going to discharge this puppy, keeping note of how fast it discharges, turning on the headlights, and then I'll go for a ride and see what it does to recharge it. Wow, well, I'll just make a note here. I turned this thing on to discharge the battery, and I came back in 12 minutes, and it had run down from 11.5 volts to 7 volts. And so I turned it off before I lost the battery, but that's really rapid. But then I turned it off and I came back a few minutes later and it had pulled back up to 10 volts or 9 volts now. So it has a little recovery. So I'm going to walk away again for a little bit. But in the meantime, I thought while I was waiting for it to discharge, I would just go over the equipment of this system, since that's all part of the charging behavior. So in this corner, we have a 12 volt, 35 watt, 235 filaments headlight bulb, incandescent, 12 volt, 35. It's a common scooter bulb. The speedometer bulb is a 12 volt LED bulb, which I had been using in my Triumph automobile as part of the panel lights, like the speedometer light or something. But it's a 12 volt LED bulb. It works really well for the Speedo. And then the parking light bulb is just a 12 volt incandescent festoon bulb, I think 1.25 inches, something like that, available at any auto parts store. The battery, as you can see here, there it is. I put that tape on there to insulate from my high-tech wiring. But the battery is here, where's the teleprompter? There we go. Battery is a Yuasa YB5LB. There it is. Bring that teleprompter closer. Can't read it. And then, so that's everything on the front of the bike and the right side of the bike. And let me set this down and see if I can take the right panel off. I did it without knocking the phone over. That's awesome. And so what I did in here was I got this this sort of universal 12 volt regulator rectifier from this guy in England. I'm sure they're available in the States. And it seems to be set to cut regulator on and off at 11.5. That's how the bike's been behaving. And so then here I have the original TV wiring harness. And so the regulator is going up and plugging into that hot thing, and then that's also connected to the battery, and all the other power wires go up to the headset. And here's the ignition channel, And here's the regulator coming up here and going into the two regulator wires here, and also over to the ignition. So that's the wire up. And like I said, that junction block is a Series 2 headset junction block because it's got so many holes in it. It's really useful. I tried one of those Series 3 round ones, but it didn't work. There wasn't enough spaces in it. And I may plug some more stuff into it. Now that I'm running 12 volts, I can run my stereo, and I can run my light show and bar, you know, the whole thing. So I'm going to take the bike out and do a charging test run, for which purpose I did my best to discharge this battery as good as I could. It's a really resilient battery. It's brand new, but it's now sitting there turned off at 5 volts. If I turn the lights back on, we see it drop to practically nothing. That's how low I ran it down before I then turned the lights off, let it recover, and it recovered back up to 4 or 5 volts. So I figure that's a good starting point. So let's start the bike up. And I'll go take a cruise and see how it recovers. So obviously the charging system's working, but I'll take it out for about 10 minutes and come back. Well, we're here. We're here in Rolando, where I grew up as a kid. I used to buy my Monster magazine comic books over there. That used to be Pick and Save, and I saw Little Oscar when the Wienermobile showed up. It was the original Little Oscar guy, rest his soul. So anyway, this is about an 8-mile ride at about 40 miles an hour down University Avenue, which contains some pretty long cruises. And it looks like, well, we're up to about like 9 volts or something now, 8 miles. So I'm going to turn the camera off and let the battery sit here and see if it does anything interesting. University Avenue at sunset. So I've been sitting here about 5 minutes, and it's still sitting right here at 9 volts, so I'm going to go home. But that's like picking up 4 volts of charge in 8 miles at about 40 miles an hour with the lights on all the way. Lights on. So I'm going to do it again. All right, so I'll check back in another 8 miles from now. Well, it's too dark out here. I just pulled up, but the speedometer light sure works. Can we get anything on the meter? Let me go get a flashlight. Let's light that thing up. So what do we got? Where's the bulb? Well, it settled down to what looks like about 5 volts. So it really didn't charge that much. So that's where it stands. It drove all the way here, and it was reading 11 or so volts while I was running, but now I'm back and it didn't charge, so I'll have to check that out. So that's it for this edition of the 12 volt conversion test. All right, well, I think I hereby decree this to be the end of my instructional video about converting the Lambretta 6 volt stator to 12 volts, because I had gone on a test ride after discharging it to see if I could charge it back up, and I had the lights on and it took forever to charge up. And then just a little while ago, I took a ride of maybe 8 miles with the lights off, and it charged right back up So the charging system's working gangbusters. There's what it came back to, that 11.5 or 12 volts. Let's turn the headlights on. That guy comes on. That guy comes on. It's nice and bright. Let's look at the headlight. That's the headlight in the daytime, the dip beam, with my crappy reflector, my old corroded reflector. So, I mean, that's really good. So this is after discharging this bike down to 5 volts and then riding it around for a while again. It charged back up. So lots of bright light and a charging system. So there you go. I'll probably try converting an AC stator next and doing it according to the Home Workshop Manual 12-volt conversion diagram in the back of the book, which uses a series parallel coil connecting arrangement as opposed to this straight 4 coils in one big long series scheme, which I used on this bike. And gotta say many thanks to my TV3, which I stole the stator out of in order to put it on the Series 2 and do all that Frankenstein-y wiring with. And I'm going to get another unit and put it in here. And then I'm going to do this bike up too. And so, take care, peace, and thanks for watching.